sulfuric acid. At this point, we take our copper nitrate solution and set up a distillation apparatus. Then we turn on the heating and distill off the nitric acid. What's happening is the sulfuric acid reacts with the copper nitrate to produce copper sulfate and nitric acid. This process is much more efficient than thermal decomposition of copper nitrate, and you can routinely get yields better than 90%. The reason why I never presented this as a viable way to make nitric acid is because I honestly thought copper nitrate was far too expensive to buy, and if you could buy it, you would also be able to buy cheaper nitrate salts that would be even better. I never realized copper nitrate was a waste product of precious metal refining, and thus essentially free. Thank you viewers for letting me know. Anyway, as you distill, the excess sulfuric acid will eventually start forming a mist in the boiling flask. At this point, the nitric acid will have completely distilled over, so you can stop the distillation. And here is our distilled and dilute nitric acid. You can purify and concentrate it using fractional distillation as I've shown in the previous video, although I recommend accumulating a large quantity first to save on labor. As for the residue, this is a mixture of copper sulfate and sulfuric acid. It's white rather than the classic blue color because when you boil copper sulfate with excess sulfuric acid, the anhydrous white version precipitates out rather than the blue pentahydrate version. My copper sulfate is dirty gray because it also has other contaminants. Anyway, we can recover copper metal and the sulfuric acid from this corrosive slurry using electrochemistry. First, weigh the slurry so we know how much water to use later. We need to have at least twice as much mass in water as we have in sulfuric acid and copper sulfate. I have about 300 grams, so I'll need 600 grams or 600 milliliters of water. Now we need to set up our electrolysis cell. Get a large beaker that can contain both the water and slurry, and get a large copper electrode. I'm using copper foil. You can also use copper. I demonstrated how to use copper nitrate to generate warning. Nitric acid and sulfuric acid are corrosive. Wear gloves when handling them. This experiment also produces acidic fumes and should be performed outside on the fume line. Greetings, fellow nerds. In the previous video, I demonstrated how to use copper nitrate to generate nitric acid without needing sulfuric acid by thermal decomposition. Interestingly enough, I got a large number of comments from precious metal refiners who had large amounts of copper nitrate waste and wanted to know if the process could be used to recover their nitric acid and if there are other processes than just thermal decomposition. There is actually. The overall idea is to react copper nitrate with sulfuric acid to produce nitric acid and copper sulfate. Then electrolyze the copper sulfate to recover our copper metal and sulfuric acid again. The whole process is very efficient and much better than having to deal with the toxic nitrogen dioxide gas as in the thermal decomposition method. You can not only cover the nitric acid, but also the copper as well. You just need a platinum electrode and some sulfuric acid, but both are used. So let's get started. I have here copper nitrate waste after I dissolve impure copper and nitric acid. As you can see, it has some insoluble contaminants, so the first thing we need to do is filter it out. At this point, I must stress that you shouldn't have any precious metals like silver in solution alongside the copper. So if this copper nitrate is a waste product of precious metal refining, then leave it to react with excess copper metal to precipitate out the precious metals first. Precious metals in solution will contaminate subsequent steps. Anyway, here is our filtered copper nitrate solution. To recover our nitric acid, we need to react it with sulfuric acid. And if you know exactly how much copper is in solution, you can add a slight stoichiometric excess and be done with it. But I'm going to assume the amount of copper in your solution is variable since it's a waste product of metal refining, where you have sulfuric acid of an unknown concentration, so you don't really know how much to add. Fortunately, we can crudely test for our endpoint. First, just make a guess and add in some sulfuric acid that you think will be enough to react with all the copper, and stir. If you precipitate a large amount of copper sulfate, as I have here, then add in some water and stir to dissolve it. Some precipitate is fine, about 10% by volume, but more than that, and you should add in water to prevent trapping of the copper nitrate. Anyway, after stirring, take out a small sample of a few drops in a vial and heat it on the hot plate to about 300 Celsius. If there's insufficient sulfuric acid, then as the copper dries, it will turn black as the unreacted copper nitrate decomposes. If this happens, add some more sulfuric acid to your copper nitrate solution and test it again. Don't worry if you use too much sulfuric acid, an excess is fine. Eventually, it should turn white when heated. This is anhydrous copper sulfate and indicates that we have an excess of sulfuric acid.
The judges really and
allow that reaction.
You made Mar-a-Lago, you know very well. You made Mar-a-Lago into $18 million. I had many offers. They said, I'll give you 19. Okay? You can take the half of the living room is what you want. So it's worth anywhere from 50 to 100 times that. And he stays with that. So he's either whacked out or dishonest. One or the other. Or both. Probably both. But he's a disgrace to the system. So I think that New York State was helped a lot today by the decision. I'll give you an example. Truth Social is done very well. It's hot as a pistol. It's doing great. It's very popular. The New York Stock Exchange wants to have us badly. And I told him, you can't do the New York Stock Exchange. You treat it too badly in New York. We don't want to do the New York Stock Exchange. And the people at the Stock Exchange are very, very upset about it. The top person is mortified, can't believe it. He said, I'm losing business because of New York, because people don't want to be in New York and they don't want to go to the New York Stock Exchange. So you can ask them about it. But how can you do that? I'd love to go in the New York Stock Exchange. But people aren't going on the New York Stock Exchange now because of what's happening in New York. Because they don't want to be attacked by a thug like this horrible Attorney General that we have in New York, the worst in the whole country. So we'll decide about Truth Social and what we do with it. But there's just an example of how this is hurting New York and New York State.
Copper wire can be used in the stock pot as well. I have used copper wire in my stock pot, but what it does do,
well, as I say,
the end of the life cycle of
you know I do because you looked at my statements. I mean, you've been examining my statements for a long time, and I have much more than that in cash. But I would also like to be able to use some of my cash to get elected. They don't want me to use my cash to get elected. They don't want that. They don't want me taking cash out to use it for the campaign. And they looked at it.
So also, don't forget about True Peak. True Peak is another very important. Hey, what's going on out there? I'm Sean Devine. Hope you all are doing well. Today I've got a new tutorial where we're going to talk about metering. We got a couple of different standards, different metering types that many of you have questions about, particularly this new standard that's been implemented into a lot of our digital music platforms, streaming platforms. It's called LUFS. Now, you're probably familiar with the older metering, which is RMS, and that's one that I use a lot on the channel. I still use it. It's still very useful, but LUFS has become more of the new standard. So we're going to talk about both of these. We're going to talk about what RMS and LUFS actually mean, what they're measuring, and then which one you should use. So also, don't forget about True Peak. True Peak is another very important metering tool. This is just measuring the loudest point, the peak in your mix or master of your song, and it takes into account the translation from the digital world to the analog world. So it's going to be true peak versus just a peak reading, and that's going to keep you from clipping or distorting on the bus. So let's jump in and let's first talk about what RMS and LUFS actually stand for. RMS is root mean square, and LUFS is loudness units full scale. So you don't have to memorize that, it's not that important, but if you were curious about what the initials stand for, that's that. But first let's talk about RMS briefly. I'm going to press play, and if you want to just keep an eye on our RMS reading over here, and then we'll talk about what's actually being measured. So we've got a reading over here of -8 RMS. I want to point out also that the level meter, which is this one that's measuring true peak and RMS, and our loudness meter, which is measuring LUFS, are the last plug-in in our stereo bus or our master bus after our limiting and mastering processing, which is in this case ozone. So this is measuring the absolute level after all this stuff is happening and what the actual loudness and level is going to be when it leaves the DAW. So just pointing that out, make sure and put those last if you're measuring it in this way. But let's go back over here and we've got the -8 RMS. So what RMS is it's measuring level, but it's measuring a short-term average. So whereas the true peak is just going to measure the absolute loudest point in the signal, RMS is taking into account a short-term measurement and it's averaging that together. So it's a little bit more accurate and it's going to give you a little bit more of a perceived loudness sort of measurement, although we're still talking about strictly level and not loudness, which we're about to get to here in LUFS. So LUFS is a newer standard that has been being used in the broadcast, television, film world. It's something that we had to follow much more closely when I was working at a post-production facility. When we were delivering our projects, they had to be within a certain LUFS range or have an integrated LUFS figure that matched the standard. So now, in the music world, we've been without a, quote, standard for level and loudness. And that is slowly changing because they have been wanting to have more consistency after we started getting into the loudness wars where everybody was just trying to make their music super, super loud. The streaming platforms, the digital platforms have said, oh, whoa, whoa, that's enough. We need a standard.
Decant the solution into my waste bucket.
I would have no problem.
And then put the solids and settle out into my stock. My new one down there. Okay, this is our prize. This is
Also
our
make me more popular.
solids.
People know it's a scam. It's a fighting trial.
That we've been, oh yeah, it's like a very fine silted mud. Oh my goodness, that's really gonna be something, man. That looks pretty good. I'm gonna go ahead and get some aqua regia on this and some heat and see if we can get this to dissolve right quick. Here we go. I'm gonna add some hydrochloric acid to this mud in here. As you can see, it's a nice fine mud with not a lot of big particles in there because I strained them out with that strainer. So I'm just gonna add some hydrochloric. Use a lot of mud in here. I'm trying to get all the pieces of excess copper and those plastic fittings. I want to get those out of there. So I'm just going to go over this and start picking everything out piece by piece. Okay, notice when I put that copper in the silver nitrate solution, how fast the silver forms on it almost immediately. Here I'm going to add a little bit of still water to make sure that the solutions are diluted down a little bit. Notice that the silver nitrate solution right here, this is sweet though. The silver nitrate solution right there was a little bit of excess here. That blue color is from the copper. Going into solution, you can see the silver cementing out.
I don't know if we're having one. We're going to be appealing right now. I can tell you that. We did nothing wrong, just like I did nothing wrong.
Very appealing to me. I don't know why.
My statements, my financial statements were conservative. They were low, not high. He valued Mar-a-Lago at a tiny fraction of what it is. He's the fraud. He created a fraud
just about everything out of there.
And her narrative.
All it's left is
She does whatever she wants.
a bunch of granules of stuff here. I want to emphasize one more time that I'm making this up as I go. I got a bunch of solids here in the strainer. Instinct tells me to burn this, to incinerate it. But I don't think I'm gonna. I'm gonna try putting that in a beaker and just see if I can get it to dissolve in some aqua regia. I'll probably end up regretting that. down here, I don't know if you can see, right there.
Office.
You look
He's been running the office. He's been signing the letters. He's been doing
here
things
is
for
this.
a long time. Nobody's ever seen anything like it. This is all done by the Democrat Party, and it's all done by Biden and his group. I don't know if it's Biden. I don't know if Biden is in charge. I don't know if Biden knows what's happening. You want to know the truth? Maybe he does. He probably does.
That's the power.
This is all done by Biden and the thugs.
If there's any of these metals,
And it's a very bad thing. It's a very dangerous thing for our country. Thank you all very much. Thank you.
Stay a solution. So what I'll do is I'll get an effective separation of the metals below copper. They will come out of solution and fall to the bottom of the stock pot as a black powder. These metals up here will stay in solution. If you notice, I have iron higher up in this list. And my waste treatment bucket is full of iron. So the process goes like this. The refining, the precious metals waste from my refining go into my stock pot. It's full of copper. In the stock pot, the copper and any trace amounts of precious metals, they trade places. The precious metals will come out of solution onto the copper, and the copper will go into solution. So when that reaction is complete, what I'll have is these metals precipitated out as a black powder, and the copper in solution. I'll have a concentrated solution of copper with these metals forming a black powder and falling to the bottom of the stock pot. Once the reaction is complete in the stock pot, and I'm certain that all the precious metals have cemented out onto the copper, what I do is I take the stock pot, set it off to the side, and allow it to settle for several days. And then I'll siphon off saturated copper solution and leave the precious metals behind to accumulate in my stock pot. Once I get the copper siphoned off, I allow it to settle just to make sure none of the solids come over with the copper solution. Once that's settled for a couple days, then I siphon this copper solution into my waste treatment bucket full of iron. In the waste treatment bucket, any metal below iron, including the precious metals, any metal below iron, the cobalt, nickel, tin, lead, and copper, will cement out onto the iron as metallic particles that fall to the bottom of that bucket, and the iron goes into solution. What I'll end up with is a bucket full of iron in solution with all these metals below it.
Degrees, I said percent here, degrees. Degrees. That's how many degrees we are. So if you told me, there's so much, by this illustration, there's so much that I could tell. By just looking at this, I could tell this is a series RL circuit. I could tell that this is predominantly a resistive circuit, but it has some reactive component. By me seeing that it's 26.6 degrees angle theta, that tells me that it's predominantly resistive and it's not reactive. If I wanted to make this more reactive, if I wanted to increase the length of my opposite side, how can I do it? How could I do it?
That's a bad one. Then I look, she got elected. But then she tried to do it with the governor.
Make it longer with my
That
pen.
didn't work. She went
He gets an
after
A
the
for the
governor.
day. You fail the quarter, but you get an A for the day. If I want to make this line longer, and by making this line longer, what effect is that going to have on angle theta? It's going to increase angle theta.
On what?
How could I do this? How could I make my opposite side longer?
Not keep their relationship professional, but to make it also personal. I'm going to show you coming up.
7821, are you clear?
If I lower my frequency, I lower my X-Abel. If I lower my X-Abel, if I increase my frequency, so for the same inductor, I increase my frequency. If I increase my frequency, I increase my X-Abel. If I increase my X-Abel, my opposite side gets longer, my voltage drop across the inductor gets longer, my power across the inductor increases, angle theta increases. You see how many questions I could ask you from just this problem alone?
Everybody realizes that I'm not giving pierogi a pass here.
I mean, it's mind-boggling. It's a big chapter. This is the biggest chapter. It really is, because everything comes together. If you don't believe that series, circuits, power, and a voltage is additive, then we got problems. You know? But if you buy, does everybody buy everything that I've sold them up to this point? Is this beyond your comprehension? Or is this right in the zone for what you've been studying? Kind of makes sense.
You'll get these nice large crystals of copper sulfate. We'll be using copper sulfate in upcoming videos, so please subscribe, rate, and comment.
Now, what if I were to tell you that during the interview that Susanna does with Tina, the narrative in which she's trying to paint in this email gets completely eradicated by her own admission?
Sorry, short quality road to Barr Station 1.
With all units, I'm starting only 79 Clearwater Avenue, 10 to 20 gunshots, incident 220, platoon Figure out Lawrence, East Williams, Sam Tom, 283 Raquel.
Actual 21 Roger.
Have not heard anything back, and I checked for that plate and all signals division, and it doesn't come up.
The next shot, 21 Roger.
11 was just left from Temple and Dillon. Suspect was laughing southbound on Temple approximately 5 minutes ago. Male black 6'1" bald, ears, black hooded sports shirt, black pants.
While we're out here giving disclaimers, this video is not meant to defame or slander Cruise.
Oh, you smell that? Oh, yeah, that's bullshit. That's bullshit, all right. By the end of the video, I think you'll learn that this is nothing more than a scorned lover trying to take revenge on someone who had a failed affair. Oh, another beautiful day, another YouTuber video. But this one is not quite like the other. This one seems like an actual factual storytelling. Despite what Susanna
copper ions being oxidized into the solution at the positive terminal is diffusing over to the negative terminal and being reduced back out of the solution. But there's actually a simple trick to get around this. This time, start with a coiled bunch of wire and place it into the bottom of the container. Put over an insulating tube on the end you're connecting to the battery. This is to slow the decomposition of this end and make the electrode last longer. Connect it up to the positive terminal of the battery. Now here's a trick. Hang your negative electrode so that it's a good distance above your positive electrode. You'll see why in a minute. Connect it up to the battery and fill the cell with dilute sulfuric acid solution. You only want the negative electrode to bubble for best efficiency. If both electrodes bubble, then you'll need to lower the voltage or raise the top electrode even higher until the bottom electrode stops.
Of my gold refining waste solutions after the gold has been removed. These waste solutions often contain platinum and palladium in trace amounts that are too small to try to refine. My stock pot is kept full of copper so that the traces of platinum group metals can cement out onto the copper and accumulate as a black mud that settles to the bottom of the container. The black mud will contain gold, platinum, and palladium that can then be recovered in concentrations that can be removed and refined. The stock pot serves two main purposes. First, it serves as a place to allow traces of precious metals to be recovered, and second, it is the first step in the waste treatment process. Hello YouTube viewers, welcome to my channel. I am sreetips, and the day has finally come for refining the stock pot. But before I do that, what I'd like to do is talk a little bit about the reactivity series of metals. In this list, the metals that I work with in my refining mostly are zinc, iron, there's some nickel in there, tin and lead, of course, when we do a gold filled scrap. Copper is a big one. Tungsten I don't see very much. We could see tungsten if we did some contacts that contain silver with tungsten backs on them, but I've never done those, so I don't see much tungsten in my refining experience here. I don't see much mercury, but down here, the precious metals, we got silver, gold, and platinum. Now, according to this series of metals here, the metals up here are highly reactive. In fact, if you took potassium or sodium and threw those metals into some water, they would react violently and explosively. So these are the most reactive metals up here. As we go down the list, the metals become less and less reactive until we get all the way down here to gold and platinum, which are very, very unreactive. These are very stable elements.
31FU301.
So take a look at this here. This text says that a metal can displace any of the metals which are lower in the series. Now what that means is, I'll give you an example. Today what I'll be doing is refining the stock pot. I keep my stock pot full of copper. Some blue. Over here we've got the copper cemented out onto the iron and is falling to the bottom of the tube there. So the iron's going into solution and the copper has come out of the solution in accordance with the reactivity series of metals. What I have here is a shot of the new stock pot with no air bubbling to demonstrate how important that air bubbling is. As you can see, the cementation process is happening down at the bottom of the bucket where the copper is. But since there's no stirring, the metals above it that are in solution are not coming in contact with the copper. So I'm going to turn the air bubbler on now and watch what happens so you can see the difference here. Now that I got some stirring action, stuff will start rising up and mixing in there and causing the metals to come in contact.
In terms of the integrated LUFS especially to the digital platform. So that's very important for using in your overall mix and masters, LUFS. But then RMS is still very useful for just judging, signal levels of, say, your microphone, or maybe you want to, measure the loudness of your monitors. It's just something that I'm very comfortable with. I think a lot of engineers have been using it for so long that I can just look up and see an RMS number and I know kind of what I'm going for, and it's just a very quick reference point for level. True peak, very important because we don't want to clip or distort our master bus or go above 0 with true peak, because some of the platforms will actually penalize you. We're going to talk more about that, but in this video I really just wanted to point out how to use these metering tools, what they mean, what they stand for, and then what the difference is, just generally speaking, between RMS and LUFS. But be sure to stay tuned for the next video. We're going to talk more in depth about how to deliver your music with a target LUFS and RMS that's going to work well on the digital platforms and streaming services. If you have any questions or comments about TruePeak, RMS, or LUFS, or the differences between these, feel free to leave a comment below. If you learned anything in the video, please like, subscribe, and consider sharing. And we'll talk to you soon. Hey, what's going on out there? I'm Sean Devine. Hope you all are doing well. Today, the older metering, which is RMS tutorial, where we're going to talk about. Hey, what's going on out there? I'm Sean Devine. Hope you all are doing well. Today, I've got a new tutorial where we're going to talk about metering. We got a couple of different standards, different metering types that many of you have questions about, particularly this new standard that's been implemented into a lot of our digital music platforms, streaming platforms. It's called LUFS. Now, you're probably familiar with.
And they put them into the Attorney General.
Down here. Add some small doses of nitric here. See if we can get some of this stuff to go into solution. That's about 3 ml.
Hi guys, welcome to Amateur Chemist. So a few months ago, I built some wood into nitric acid, which was a really cool project, but I ended up producing only a tiny amount of some synthesizer with aggressive wood, and since then, I haven't worked to find a way to make nitric acid from an over-the-counter product in a way which would result in an actual
Very much in our filter.
After some thinking, I figured out that nitric acid can be ready to be made from a certain kind of fertilizer, and that it is actually supposed to be white. I know that I said that many times on this channel, and it has in common with nitric acid, but as I showed you many times, they are actually connected because of the weird world of chemistry. You see, most fertilizers,
Go ahead and precipitate now. Some sodium metabisulfite. We'll go with first one.
So they've adopted the LUFS, and there are some integrated LUFS numbers now. You hear stuff like Spotify, their integrated LUFS standard is -14. All right, so what is the LU in LUFS? What's a loudness unit? All you need to remember is that it is the equivalent of 1 decibel. LUFS is measuring perceived loudness, so it's different than the decibels that are being read by RMS. So let's talk about the difference between LUFS and RMS. So whereas RMS is only measuring that short-term average of level, LUFS is measuring many different things here, and it's doing it in a way that is measuring perceived loudness. So our ears hear loudness
was the baking soda volcano, so I decided to gain some chemical skill and come back to it later. Now, after 2 years, I finally feel confident enough to take on this project, and the first thing that I have to do is to find out what is the fertilizer composed.
So if you look up here, I'm going to press play again, and just keep an eye on this M, the S, the I, then the LU range, and then the I again. This is the same reading that's up there. It's called integrated. So let's talk about what those we're measuring up here. The M stands for momentary, which is just at that very moment, what is the LUFS reading at that point. So that's going to be closer to our RMS reading. They are going to differ a little bit, but then the S is short term, so that's going to be more of a short term measurement, and it averages those together. The LU range is just referring to the difference in the quietest points of the signal that's being fed in here and the loudest point, and it's referring to it in terms of an LU, or a loudness unit. And then the I is integrated. So the integrated is taking into account the loudness over the entire span of us, playing or feeding the signal through it. So when I press play and stop, that entire segment is being taken into account to calculate the integrated LUFS. So the integrated is the one that you're seeing as the standard for music, because it's measuring the entire song's integrated LUFS. So if you see -14, that is referring to the integrated in terms of Spotify's standard. So that's the one that you want to focus on. So what should you use? Should you use TruePeak, RMS, or LUFS? My personal suggestion is a combination of all three. So RMS, it's not as accurate in terms of perceived loudness, obviously, and I think it's very important that you do want to start getting comfortable. I'm using LUFS a lot more because it's becoming the standard. So I need to be aware of where I want to deliver my sessions for clients.
It always makes me happy. So, a lot of things happened today. This is all about election interference. This is all run things, meaning Biden and his thugs, because I don't know if he knows it.
University Anthony, University Evans, Preston, Fraser, Oakland.
At least 50, maybe 100 times more. Think of that. This is the fraud. They're creating a fraud and they're hurting the state so badly. And then I can't go into the New York Stock Exchange because I can't do business, because I don't want to do, not because I can't, because I don't want to do business in Europe. And the people at the New York Stock Exchange, I can tell you right now, they're very fine people, they're not happy. I might do that. I have the option. But if I have to spend $500 million on the bond, I wouldn't have that option. I'd have to start selling. I don't have to sell anything because I'm a phenomenal company. I built a phenomenal company. Someday we'll actually report that. I built a phenomenal company that's very low level, unbelievably low level, with a lot of cash out of it. Why should I let a crooked judge make a decision to get $450 million that allows me to spend very little money on my campaign? If I say, I'm not spending much on my campaign, I might spend a lot of money. But I should have that option. A crooked judge should say, we're going to have you post a bond and take all of that money that you spend.
This whole concept